Hello, thank you very much. Today we're going to talk about context capture. We're going to focus on combining laser scanning with photogrammetry. So I hope everybody's familiar with photogrammetry to begin with and LiDAR as individual things. I will be covering them, the basics, but if you have any more details, you could follow up with me later. Uh, Everybody could see my screen right now. Like I said, first we'll talk about describing the technologies. You don't need a full understanding of this to understand how the algorithms work, or basically photo-based acquisition. We need to focus on overlap and several things that I'll cover today. Uh, One technology is LiDAR. LiDAR is collecting of point clouds. So basically, you're going to create a laser is going to go out and measure distance and angle, come back and give you an XYZ location. It's very accurate, but it does cost a lot more money. So then we go down the avenue of photogrammetry. Photogrammetry has been around for at least 30 years. Many times it was done from airplanes, taking photographs with overlap, and then through stereoscopic machines, we're able to calculate the Z value of everything and kind of create 3D maps. Nowadays, since technology has increased a lot, digital cameras are a lot easier to use and easier for us to obtain. So with context capture, you can automatically generate high resolution 3D models with just taking photographs. You could use a standard digital camera. DSLR cameras are the common ones that you're going to hear. But you could also use a smartphone. Everybody has a smartphone in their pocket. All these phones have cameras, so as long as it's a digital camera, we're able to pull in the metadata information that's with it, so we can get the sensor size and all the information that the software needs. Some people are also mounting cameras right onto a drone, or you could even, for larger projects like city-size projects, you may want to look into using a helicopter or a Cessna airplane. Here I'm showing you exactly what a point cloud looks like. As I said, they are just dots that are floating in space. These do have color codes, which were produced by the scanner, which is helpful for us to kind of tell the difference of one dot next to the other one. But we're still seeing things like the grass through the building, which kind of makes it really hard for me to understand what the front is of the building, the back of the building, since we are able to see through this. If we look at this now, just the mesh created from the point cloud, we see that it fills in everything in between the dots with the mesh. This is a lot lighter, easier to work with. You also notice how the wires overhead are very clean, because that was used with LiDAR. Sometimes very thin objects don't come out great with photogrammetry unless you get enough pixel resolution on it. So let's compare the two side by side. I talked about the point cloud. We see that here in the upper left. Now, there are some techniques that we can use to enhance just that point cloud. One example is raising the weight of it. So I could thicken those points up, which definitely did help a lot. But once again, I'm still able to see the grass through there. And as I start working with this, I'm not really sure if I'm picking on a wall here or maybe a wall throughout the back of it. So if we look at that side by side with our the final product, which was produced from a point cloud and photogrammetry, we're producing a mesh there, which is very lightweight, easy to use, and accurate. As you see there, the lines are still very crisp, so we're not losing any data that we acquired from the LiDAR. Here is another example of the detail. I changed the angle so that we can see along the sky there how the wires came out. They're very crisp and neat. Many times for a railroad project, this is important. So let's talk about the advantages to using LiDAR. One, it provides accurate data, which is fantastic. You're getting very high resolution accuracy, which is required for when you're doing engineering type plans. The capturing can be done at night, so that's if no color is required. So if you're looking for just a point cloud of XYZ, you could do that in the dark. You don't need any special lighting. If you are looking for RGB values from it, you would need lighting so that it can get good colors. Thin structural elements can be captured, as you saw there with the wire. Using LiDAR was able to pick that up. A lot of lattice, things like that, are easily picked up by LiDAR. Now let's talk about some of the disadvantages. Well, the hardware is relatively expensive. Some of these units, they're starting over $30,000 for good, high quality machines. You also need training. Most of the time when I've done this work, it was professional surveyors doing this. They're using control, and the system also needs to be calibrated in their training they go through every year. So also laser scanning of busy urban areas can be noisy. So that's noisy is a term that we use in the industry when there's erroneous data in there, and that's caused either by people walking by, cars moving by, sometimes particles of dust or water in the air can also cause this. And also the data from very large surveys can run into terabytes and very difficult to manage. I know we have a lot of computers that they're getting faster and faster every year, but some of these projects are using billions of points. That being said, that can choke some of these machines. Using photogrammetry and creating a mesh allows it to be very lightweight, even viewable on your mobile phone. So let's talk about the advantage of photogrammetry. The hardware is inexpensive and basic training is sufficient. As I said, you don't need to be a photographer. You need to just understand, get your object in focus and do enough overlap. We're not covering the acquisition today, but we do have some training available to show you how to acquire your photos. Maintenance crew can carry basically their smartphone, or if they have a very inexpensive DSLR camera, they're able to go to a scene, see an asset that maybe has some damage or needs some maintenance. They can quickly take a couple pictures of it, even using a Bentley application on their phone, and process the images, and within a few minutes have a 3D model of their asset. As I said, it's relatively quick. If you have your phone in your pocket, you pull it out, you can take 15 pictures in less than a minute. UAV-based capture can safely provide accessibility and good coverage. So I'm going to show you some samples of a railroad project. Now, you could use a laser scanner to do the entire rail project. It is important for rails to be very accurate when they're doing their design to it. That being said, it also costs a lot if you want to cover the entire scene, and maybe you don't need that. So you could use a drone or a unmanned aerial vehicle that could use photography to capture your entire site, and then you could just focus on your areas of concern with the scanner. Raw data, for example, the photos can be used, or they're valuable without significant processing. So I'm going to show you how we could take some of your assets and go back to the original photo so that you could see the highest resolution. Now, we were talking about photogrammetry advantages. We also need to cover the disadvantages. Capture must be performed during daylight hours, ideally in a diffused light. So you don't want to use flash. You want a nice bright scene. Thin structural elements do not reconstruct well unless you have enough pixels on them. But typically when you're doing a site, things like overhead wires may not have enough resolution on them to really model correctly. Highly repetitive structures can cause reconstruction artifacts. If you have a plain white surface that has no texture to it and you cannot distinguish between one part to another, that's hard to do with photogrammetry. Quality highly depends on the photo acquisition process. So although I say it is very easy to acquire your photos, you do need enough overlap. You need to make sure you cover enough area, and um, basically every part of the scene that you want to model, you need to have several photos of that cover that area. We do have an acquisition guide which easily helps you through that. So let's talk about combining these two technologies, LiDAR and photogrammetry. What are the advantages to doing that? Well, we can cover large areas. As I said, photogrammetry, we could use a drone, cover your entire site, and then use LiDAR on the more important area that you need to focus on. It creates a lightweight mesh. You can also view this on your smartphone, tablets, anything like that, view through a web browser. So it's very lightweight, easy to use. You can also reference this right into your CAD platform, which also is very light and easy to work with. You'll still have that level of detail. So you have this lightweight mesh, but we are creating scalable meshes. So as you zoom in, you will see a lot of detail on features like the rails and the nuts and bolts that are on that rail, which I will be showing you. Lighting's not as important. If we're Also using LiDAR with it, LiDAR doesn't matter if there's light or not. It's still going to calculate that angle and distance for that laser beam and give you an XYZ point. Then we could use photographs to acquire the colorization to it, which we could acquire during the day. So that's very helpful. Many times you want to do scanning, LiDAR scanning off hours, which is at night, so you don't have many people walking around and maybe the rail lines aren't running during that time. Collect from uniform surfaces. I do have an example, and as I mentioned, if you have something that's one consistent color and does not have texture to it, the software cannot tell the difference of one pixel to the other when they're both exactly the same. That's the case where you may see voids created in just your mesh. Where LiDAR, it's irrelevant of the type of material, it will just reflect off of it and give you an accurate measurement. So of course, all this is going to save time. If I can do most of my site in a couple hours using a drone and then focus all my remaining time on the areas that are very important to me, I definitely save a lot of time. And if I can save time, then I'm definitely saving money during this process. So let's look at a couple of these things side by side. This is the aerial photogrammetry. It does not look bad at all. If I take that texture off, and the texture is what I'm referring to as the image, that's the image that's draped across this mesh. If I remove that, you can actually see more detail of how the mesh looks. Now, what you're seeing on the left is created just from an aerial drone, so you're not getting a lot of detail of that rail or the nuts and bolts that are connected to it. If we look at the combined image, yes, it does look a little better, but I'm definitely not, it's hard for me to tell really how much better it is with that texture on there. So I'm going to remove that texture so that you really can see the accuracy that we're getting out of this. Uh, we very accurately can see the nuts and bolts and tie downs on this down to the gravel and the wires in the background. If we look at this close up with the texture, I'm able to see all these tie downs. This would give me accurate measurements, be able to look for deformities in this rail. And if we look a little closer at this, just so that you can really grasp the detail that we have there, we could see those square bolts on there are very clean and easy to distinguish. So how are we creating the mesh from the point cloud? I'll walk you through the step-by-step procedure here. We're going to create a new project. We're going to import your point cloud data. We're going to select your spatial reference system. That's important that both of these are in the correct system so that they can tie together. We're going to create a new reconstruction and submit the production. Now all this is walking through step by step, so this is recorded. You could follow through after. First step that I'm going to do is import my point cloud. Now I'm using E57. We can also use a PTS file as long as we have the location. E57 is a very common format in the industry. I'm going to select my coordinate system. And here we can see that it was imported from an E57 and automatically adds that to our description. We can see the metadata over on the right side that comes through. Now the color mode, we can use the color or intensities. Intensity is that reflection calibration that you're getting back from the surface that the laser beam is going to. We can also see each scan world that was captured and its location during the scan. That's important for us. We see those yellow dots are representing where the terrestrial scanners were. Now for this demo, we're just focused on this building. Now I know you're seeing just a few dots and looking through this. That once again is from the point cloud, how they are just a series of dots, and if they're thinner, you can actually see through them, which is why we want to combine the photogrammetry with this. Now, I do recommend cutting things into tiles. It is based off of the power of your machine, but there are some benefits to doing it by tile. One benefit that I appreciate is being able to see my results sooner than waiting for the whole thing to process. So each tile, as they're done, you'll be able to review them and make sure you're going in the right direction. Also, if you need to edit, sometimes there's some anomalies in it that you need to edit and pull out. So we could take that and export just the one tile out to MicroStation and do our touch up and clean it, and then send it right back to ContextCapture to update our mesh. Here we see the results of this lightweight mesh that was created from the points. And once again, turn the texture off. You can really see the detail of the wood. So let's look at creating the mesh from the point cloud and the photos. It's a combination of the two. So once again, pretty similar procedures. I'm going to import my photos. Then I'm going to perform my what I call AT, arrow triangulation. We're going to import our point cloud, ensure both the point cloud and the photos are perfectly referenced. We'll create the new reconstruction and submit a new production for our new mesh. Photos are easy to add. You could do it by directory or by individual photos. And you can preview them, make sure that they're looking the right way. As you click on the actual camera position, you see a preview of the photo in the upper right. And most of these wizards, you just say next, next, next. I do advise that you look through your settings, be aware of what they are, but we do pick default settings that work in most scenarios. AT process, with every release that we come out with, we're doubling it. So AT times that you may see reference to each release are getting faster and faster. Here we point to our E57 file now. We also have our photos in there, now our point cloud file. We're going to once again select our spatial reference system. Once again, we review our settings on the right, make sure that we see the scans have come in, our XYZ positions of them. And here's the combination of our two. We're seeing these are key points created, which will then be tied together to create the mesh. The yellow dots represent where the terrestrial scanners were located. They were on tripods. One thing that I want to point out here is you see that we're changing the area of concern that we're reconstructing. It will save you a lot of time. When you're taking photographs, you're getting a lot of things in the distance, which are very helpful for your parallax to calculate where the camera position is. But when you're doing your reconstruction, creating your mesh, I don't believe you need everything outside of there. That is stuff in the distance. So I recommend changing your spatial constraint to tie it into just the area that you're working with, create a nice small mesh for you, very easy to work with. And now you see our results. We're getting the best of both worlds. Very good quality photo realistic model which also has the accuracy of the LiDAR. So I mentioned that you can view these photos individually. So we have an MDL you could run. Uh, Basically, we're going to go in, and since this model was created from a few hundred photos, many times these photos are used and just parts of the photos are overlaid on the mesh. Things like nameplates may not be so easy to read depending how close you were, but you could always go back to the original photo. The hard part's sorting through the photographs and finding out which one is really looking at that nameplate or that area. With this procedure, we could just pick somewhere on the model. It quickly rotates you to the model view. You can see where all the photos are, and you can see that original photo there in the bottom right view there. So that is the original high resolution image. You could zoom in and see the level of detail that you had during that photo acquisition. This allows you to have a nice lightweight model. Maybe the resolution won't be so high, so you're just using it as a background. But if you really need to see some areas of details, you could go back to your original photos. Or you can also make your mesh very high resolution where you could zoom directly into the nameplate and read that as well. So let's talk about visually seeing your data. This is an airport that we did down in Nash County. Basically, it's was done with a drone, just a less than 100 photos, but we went out and grabbed some GIS information. Most of this is very free. Uh, Counties, municipalities, you go to their websites and just search for that county and GIS, and you'll find a whole bunch of shape files that you can get. Now, these shape files are 2D files, but they have the metadata, the attributes that's attached to it. So in this case, we just point to all the shape files for parcel information, and I can quickly just pick on an area of the mesh, and it's actually looking at that 2D shapefile to create these shapes that are clipping this. So I can see the actual parcel outlined right on my 3D mesh. We could also use this method to query information. So since it's in there, we could use some of our search, the file explorer, so that we can search through this file, look at metadata that pertains in there. And you don't have to know everything. You can have just some partial information. It's very helpful if we're looking for property owners. Maybe we don't know the whole name, but we know that it contains part of, say, Port Authority or Airport Authority. And we can see which properties then belong to the Airport Authority. So we have several of them there. It highlights it all for us. You could do this for your assets. Any metadata that you have, it's very quick to link it in 2D. Also, if you have 3D data, we can use 3D shapes to do that as well. I would like to show you one more sample here. On the left, we see what was done with photogrammetry and with LiDAR. On the right, you're seeing just what was done with photogrammetry. So as I mentioned, areas that have no change in color, very flat, um, just no deviation and no texture, don't come out very well in photogrammetry. So you'll see on the right, those flat panels kind of just came up as voids, where those are a great case where you could just use LiDAR on that part of the wall to fill that part in for you. And what does sets us apart from many of our people that we're working with in the industry is our scalability. Um, you'll see here, this is a facade of a building, this is an opera house in Paris. But very quickly, we come away from it and we can see the amount of detail that we have on the entire facade because we took pictures from street level. But then we also used airplane to cover the entire city. This is not a small mesh. This is one mesh though, and this can be viewed right on your iPhone because we are scalable. There's not a limit to how much data we can add in here. We load the level of display as you need it at that current time. I would like to wrap up and talk about um, the ContextCapture trial. You're welcome to go to www.bentley.com/ContextCapture trial. You can download your complimentary version of that. We have some sample data sets for you to work with, and we'd be more than happy to help you through the process. I also want to talk about the Connected Visor. I want to introduce you to this. It's a one-stop place where you can go for support and learning recommendations. What if you didn't have to search Google, YouTube, Bentley Communities, and several other sites just to find the learning software, workflows, maybe best practices? What if you didn't have to wait for someone else to find this information, waste time searching for different sources? What if you could learn and improve the skills in the product, save time and effort without having to open another browser window? Don't out on any live learning opportunities and discover all the virtual classes, webinars, SIGs, which are special interest groups, and more right within the product. You're going to get recommendations that are personalized for you based on how you use our software, the types of projects you're working on. What if you could do all this without having to download and reinstall another version of our software? We now have one file that you can download. You'll have access to hundreds of virtual classrooms, hands-on workshops, video lectures of hundreds of softwares, and you can also interact with thousands of subject matter experts just by installing the one application. This is how Connected Visor looks inside of a Bentley product. You can see how the drop down menu on the right hand side, you can see how videos would play right in the middle. When Connected Visor is launched, it's going to automatically display the most recent learning, Bentley Communities, and YouTube content. You can also filter. So here we can focus on what we want to see, whether it's through the B Communities or on YouTube, simply by a couple clicks. And once you've found the content that's relevant to you, you can just view it simply by clicking on the title. Doing this will display all the models that are included with the courses and the model descriptions. You can play the video directly from within the product on a second monitor, or you can watch the YouTube video the same way. And also, we're pleased to introduce the Select Connects edition, the most significant enhancement to Bentley Select program since its inception. We are expanding our benefits to assist our users' organizations in their journeys of going digital. These new benefits deliver personalized learning for each user, mobility advantages for individuals, and collaboration services for teams. We are hosting a three-part webinar series starting next week to help you understand more about Connect services. We hope you will attend all three of these webinars in the series so you will gain an understanding of the newly introduced benefits of your Select subscriptions. If you need more information, you can always go to bentley.com/context capture.